In this episode...
Wow. That's a leading question, isn't it? Crikey.
You testing me?
Yeah.
You can't box it in because it's not an infinite energy machine.
What an exhaust air heat pump
I'm not.
No, neither myself, no. So we'll go through this together, Mars.
This push towards doing the matte black look, that's what they're loving at the moment.
I've got photos of the water halfway up the unit, and I was like, oh, that's written off.
And there was a huge blue patch beneath the radiator.
Rick, do you think it'll go the same way as bathroom suites and NIBE will do avocado green soon?
But actually, that's a really dangerous thing to say.
I think it's a boy band when you say it like that.
Yeah.
Like,
Welcome to another episode of Homeowners Q&A. I'm your host Mars, and today we're discussing heat pump installations in challenging properties like flats, apartments, and other tricky spaces. Joining me on the panel are three experts: Rob Stevens from Heat Force, Rick Clarke from NIBE, and Barry Sharp from Renewable Heat. But before we get started, we'd like to say a huge thank you to NIBE, Europe's leading manufacturer of air source, ground source, and exhaust air heat pumps, for sponsoring this episode. Flats and apartments in densely populated areas pose unique challenges for heat pump installations. Air source and ground source heat pumps can often be unsuitable due to space limitations for outdoor units or ground loops. Noise concerns also arise with multiple households living in close proximity. One solution that addresses these issues is exhaust air heat pumps, or EAHPs, which utilize extracted air from inside the building to provide heating and ventilation. We've provided a link in the description if you'd like to learn more about EAHPs. Thank you again to NIBE for supporting this episode and for their continued innovation in developing heat pump solutions for all types of properties. Now, to kick off our discussion, Rob, what are the most common challenges you face when installing heat pumps in older, hard-to-insulate properties?
Hi, so first of all, thanks for having me on. That's a very good question, and one that I think comes up quite a lot in industry. So when you talk about older properties, I think what people think of most is like an Edwardian-style house or something with stone walls or anything that might be very, very old. One of the main challenges is obviously the heat loss side of things. With insulation levels, we know that the better the insulation, the lower the heat loss of the property, which means that generally a smaller unit can be fitted. When you have a higher heat loss in a property, you start to need a larger unit, you might need multiple units, and that can cause additional considerations for the homeowner when they are wanting to go for a full renewable system as opposed to using a hybrid, for example. Finding a unit that's appropriately sized to work in the property in terms of the heat load is probably one of the biggest challenges. The second one is going to be working with the existing pipework, which might be very, very old. It might have been sized to deal with a high temperature system like an oil boiler, and with heat pumps having higher flow rate requirements in terms of the mass moving through the system, we also find that there's a need sometimes to amend or sometimes entirely swap out the pipework to make the system as efficient as can be.
So Barry, you're based up in Scotland. Fair to say, colder, wetter, a lot of period properties. Do you find them challenging to fit heat pumps into?
20% is Scottish housing stock was built before 1919. In actual fact, it's 19.19% if you're not doing the math properly. I'm not finding hard to heat properties hard to heat. I think the way we measure heat losses isn't accurate for old buildings. So I done a presentation this recently at the Green Homes Festival in Edinburgh, part of the Fringe. We've been fitting in pre-1990 houses for 10 years now. The U values that we assume these old buildings have got are nowhere near it. The air changes are nowhere near it. And if you start factoring these things in actual fact, you can get to work in most houses. The only houses that we will avoid, if I see single glazing, that's what I'd class as hard to heat. But as long as you've tackled the main drafts, you've tackled the loft and you've tackled the windows, a heat pump will work in your home. So what makes it hard is not the technology of the heat pump, it's just upgrading the heating system and how difficult it is to move out in the house. That's the bit we're finding hard, because you're working in older properties which you don't know what you're going to find when you lift the floorboards. That's the main factor.
A lot of that work, though, to getting those kind of properties efficient is going to require quite a lot of work to heat emitters and piping, as you said. So how reluctant are homeowners to upgrade or change their heat emitters as part of their kind of central heating overhaul?
A lot of times when you get into pre-1990, the heating system's been in for 30 or 40 years anyway, so it's the chances that they've missed the microbore. They've got decent sized pipework already. Another thing is that the heating system was probably designed before any upgrade happened in the house, so there are a lot of times they're quite close. But what we kind of tell customers to do is to stop trying to eat the elephant in one sitting. Think about the house on a journey. So let's look at what we can get away with today with minimum disruption and then plan for lower temperature down the line if it's feasible. We can get a heat pump to work at a higher temperature, and then start planning some of this work. Because I don't really think we should be going into people's houses and turning them upside down just to get the heat pump in. We should be doing this at points of the house as well. So if you're thinking of doing some sort of major work in the house, so we've got a kitchen coming in, or we're doing some work in the decoration, that's your trigger point to do the heat pump. Or we're getting the windows replaced, that should be a trigger point because the house has got disruption. I think we need to start looking at the life of the house and where to plan these things in.
Planning to install an air source heat pump? Then get your copy of Bodge Buster. It's packed with must-ask questions, real homeowner insights, and a practical guide for a smoother installation. Available in print and on Kindle, link in the description. When I look at the Renewable Heating Hub forums, a lot of the cases, in fact, probably I would say 99% of them, is all people that live in houses where you have got the ability to put an air source heat pump in. Things like flats and apartments are a lot trickier to put an air source heat pump in. So, Rick, how does one now start to tackle the housing stock that are flats and apartments?
Oh, that's a good one. I mean, you can, obviously, the first answer is you can potentially fit air source heat pumps, as the other guys on the call will know. Often the problems associated with that outweigh the fact that, do you really want to fit an air source heat pump? If it's 5 stories up, can you in the first place? By the time you've put scaffold in, cherry pickers, etc., it starts to add up financially and it starts to become a bit of a headache for everyone involved. A lot of the time it gets thrown out for good reason, and that's forgetting maintenance. There's a lot of companies now are point blank refusing to go back and maintain or fix heat pumps. I've sort of heard of if they're above a story, for example. Certainly the way we approach it at NIBE is exhaust air. That's what we're finding is the sort of product certainly on everyone's lips at the minute. I'm sure the guys on the call are aware of what an exhaust air heat pump is.
I'm not.
No, neither myself. No, so we'll go through this together, Mars. It's essentially the same as as an air source heat pump. If you kind of have that in your mind, it's more where's the heat being drawn from? Where's that air being drawn from? An air source heat pump sits outside. It's taking that heat from the air all around us, all around the heat pump. So the difference with an exhaust air heat pump is that air is being drawn from inside the property. Sometimes I get told off, or I'll laugh at saying this, but it's sort of commonly referred to as the sort of damp, moist air. That's where the heat is, or more of the heat is. Rooms like bathrooms, kitchens, en suites, it'll draw the air from there. You've got that excess heat inside it. Uses that via the same process you would get inside an air source heat pump, i.e. the vapor compression process. Then it expels it. That then sort of drier, colder air is expelled to outside via an exhaust duct. That heat inside the heat pump is then transferred, again, similar process, to either a hot water cylinder, which is integral to the footprint of the appliance, or to radiators, underfloor, fan coil units, however you want to heat the property.
So if you're in an apartment building and there are, 100 apartments, does everybody have to implement this? Or if just one apartment wanted to do that, can you just do it in one? I mean, how does that work?
Yeah, I mean, again, it's similar to what Barry was saying. I really do genuinely think that's a fantastic approach, the piece by piece, piecemeal approach. Just on that, I think a lot of the public are scared to death, really, that people are going to come along and go, yeah, it's £15,000 off the top of my head for the install, but actually there's another £10,000 of work you've got to do. Well, hang on a minute, no, off you go. We're not going to have that done. To answer your actual question, you can take it as it comes. Each person can have it installed, or you can take a holistic approach and have the entire block of apartments, let's say, converted to run on exhaust air. They are a standalone unit. It's not an industrial setup. It's a domestic type unit. So yeah, each individual apartment would have the heat loss assessed as normal. Potential for the ducting, is there any ducting in already? If not, are there viable routes for the ducting? And then look at, can the product be installed? And if it can, yeah, there you go. Each individual flat, one at a time.
You're listening to the Renewable Heating Hub Homeowners Q&A, empowering consumers with the knowledge they need to make smarter heating choices. Rob, we got a question from a homeowner, and they asked, I have a heat pump that was installed in an 18th century cottage with the solid stone walls. It's very difficult to insulate. How can I make the system run more efficiently without major structural changes?
Okay, so they've already got an existing heat pump and they want to make it more efficient. If they're looking to not make any major structural changes, I think it would be looking at things like the windows, for example, the draft proofing, whether they've got more recent doors, maybe fitting internal wall insulation or external rendering or something that doesn't, require major upheaval or changes to the actual construction of the property. The other way to look at it would be about the control strategy. So again, depending on the manufacturer of the heat pump that they've got, just checking whether or not it's set up in the most efficient way, whether the weather compensation curve is correct, and I guess looking at the number of thermostats and how the heat pump is actually controlled. There's a lot of different factors, but they can obviously get a professional to come in and have a look at that, and look at any one of those options and see whether or not that's the right solution for improving the efficiency of the heat pump.
Can I add to this?
Yeah.
You're right. You want to get a better efficiency. You want to get the running temperature. You want to get the heat pump running sweeter and a lower temperature. So if you can't get that, then start looking at the low-hanging fruits in the property. One of the companies we work with, Local Homes in Glasgow, who do assessments of properties, they do air pressure tests and thermography graphs. Go and find out where you're losing your heat, because you might find little low-hanging fruits like, hang on, that door's really drafty, let's get rid of that. Start tackling those little things, because that'll start making a difference to it. Your ventilation losses are about a third of your heat loss. So if you've got a drafty house that you don't really pick up on. For example, my own property, I bought a 15-year-old house. I thought I'd want to watch because I had a ground source in it. Couldn't heat it, couldn't figure it out. The builder hadn't put insulation in the walls, that's why. It took me the first winter, I was like, why is this cold in here? I know this should be working. Cut a hole in the eaves and found out it just missed the eaves out completely. These might be happening in properties. You could find lots of little things like this to just make the house more and more comfortable. And the more comfortable you get it, the lower you're running the curve or the running temperature of the heat pump, the more efficient it'll become.
I actually once had a friend who had a similar thing, kept going back to this house, could not get his head around it. It was about 4 years old, this house, and he tried everything to work out, why is this house sucking the heat out of the property? What is going on? And something along the lines of the floor never met the wall, and they put the floor in over the top. So he went around with a heat camera, and the last thing he did, he zapped the radiator in the front room. Just thought, I've done everything, I zapped it. And there was a huge blue patch beneath the radiator. And because it was beneath the radiator, it was having an effect of kind of disguising. They weren't noticing the drafts. And it was just walloping the heat out of this house all day long. So he pulled the floor up, cut some of the wall away, took the radiator off, and just filled it. Probably not the ideal thing to do at the time. He just filled it with expanding foam. And, 2 weeks later, these customers were going, can you come back and turn the heat down, because it's so unbearably hot in the house? And that was the only thing he did. Literally just filled this, maybe like 2 foot gap underneath this radiator. Bonkers. It's such a simple thing.
The problem is the gas boilers mask all that, because you can just power through it. You don't never see it.
Yeah, exactly.
I think that's a top tip though, Rick, because one of the first things that we did after we struggled with our air source heat pump, we actually got a thermal imaging camera. We never had, the massive gaping hole that you've just described, but we did find certain places that were leaking air out, as the corners of windows where some of the little insulation was gone, or we just filled all of those little gaps. It took us a fair amount of time. We put additional skirting boards along the bottom where we felt drafts. Within about 6 months, we saw that the house was notably warmer. So Rob, is that something that you would potentially advise to people that are struggling with insulation, is to maybe hire a thermal imaging camera for a day and just and find these things?
Absolutely. I mean, if it's within budget, I was just thinking it's easier with newer build houses, and obviously that's not the topic for today, but because they've had things like air pressure testing, they probably have a full data SAP calculation as well, and all this stuff that will really nail down on the heat loss. But definitely, if you do have an older property with a heat pump and it is struggling, that is a fantastic idea, is to ultimately is getting a professional in to have a look, or hiring a camera and just seeing where are those areas where you are losing the energy. And like the guys have just said, looking at the low-hanging fruit, if you've got old windows and there's a rip-roaring draft whistling through them, just changing those windows, especially if they're due to be changed anyway for whatever reason, getting new doors if they're a bit old, that can make a world of difference, because as the guys rightly said, about a third of the heat loss of a home comes from the air changes.
We're seeing that just now, because we've started doing a couple of air changes on pre-1919 property. When I say pre-1919, I mean built before 1919. Sibsy reckon the air changes should be 1.5 times an hour, but we've done air tests and it's generally 0.5, so it's a third less. And we're seeing this right across central belt of Scotland, that the air changes are really good in these old buildings that we just didn't really pick up on.
It's a very common thing, isn't it? I think, guys, when you find that the recommended air changes are, like you said, 1.5, it actually can massively over-egg the heat loss of the property. There's a compliant way of calculating the heat losses, which obviously we have to use for everything. But in reality, people will find that if those air changes are used in the calculation, the performance of the heat pump will actually be far better, because the heat loss is actually a lot lower than it is.
Have you got questions about heat pumps and renewables? Then head over to the forums at Renewable Heating Hub for practical advice from thousands of fellow homeowners and heat pump users. Rick, this is a question that we get asked so much. Is it possible to install an air source heat pump in an open garage or semi-sheltered area?
Wow. That's a leading question, isn't it? Crikey. It's a tough one because you've got sort of my like installer head and my or former installer head and my logical head and my sort of almost corporate NIBE head sort of fighting here. The initial response would be yes, theoretically you can somewhat install these things anywhere. But actually, you know, that's a really dangerous thing to say because, you know, sometimes these things go out there and they get answered like that. Oh yeah, you can install these anywhere, it'll work. And like Barry said earlier, yeah, you can make a heat pump work in any property. There's no question about that. There's so many reports have been done. Will the heat pump work? I think we're past asking that, or we should be past asking the question, will it work? Of course it'll work. Will it work as you want it to and efficiently? Almost certainly not. You know, there's some great videos of people putting all sorts of things around heat pumps and going, look, it's still pumping out 60 degrees. Yes, it is. But actually, when you go back and you really dial down into the COP or the SCOP, you know, you start noticing it can have a massive effect. Things like microclimate get mentioned a lot, you know, and that really is just a recirculation of that intake air, and it's being recirculated, or at least a portion of it will be. It keeps getting colder, less heat in that air to be used by the heat pump, and the knock-on effect of that is you start getting a spiraling downwards of the efficiency, and obviously the output from the unit will then suffer, and before you know it, not only got a hideously inefficient unit costing you quite a lot of money to run, you're probably going to start noticing that actually it isn't giving out the heat after all. I would argue by the time you reach that point, though, it's probably a bit late. You're probably already bankrupt by then. It's not something I would recommend as a whole, no.
I've actually done it. I've been at this almost 20 years, so I've made all these mistakes. I thought I was being smart one time because I took an oil tank out of an old coal bunker and I thought, that's a great relocation for a heat pump. I'll just stick it there. And the first winter I came back, it had about maybe 300 mil of ice and the whole thing had moved up. It was defrosting and just instantly freezing again.
For the homeowners that might be, I guess, watching this and wondering, why can't I put it in a garage? Why can't I put it in this nice enclosed space? They might be used to seeing all sorts of plant room kit and different gubbins for machinery being placed inside. Contrary to popular opinion, a heat pump is not a magic box and it doesn't produce heat. It moves it, it condenses it in a way if you want to, from low grade heat to high grade heat. So within any system, we go back to the basics of physics, you cannot create energy, you can only move it. When you run out of energy to move, that's it. And essentially, if you get that, we're talking about the recirculation of air through a system, the heat pump will start drawing the air, and as it keeps going through every time, the molecular energy, sorry to kind of bring it on a bit of a nerdy level, but that energy within the air molecules, because that's all energy is just movement of molecules, it gets less and less because it's being drawn into your house. So eventually, there's not enough energy in those air molecules anymore, and your heat pump's going to struggle or it's going to drop in performance. You can't box it in because it's not an infinite energy machine.
You want to take the energy from the air, and you want that cold air you want to move as far away from the heat pump as you can so you can get some new stuff in the back of it. If it's got a chance to bounce about or got a chance to stay in the same place, then you're going to keep going round and round and round.
When these first questions started to come on, my maths is absolutely appalling, but I did try and break it down, and I eventually worked out, and I think this is correct, that a 10 kilowatt air source heat pump requires around 2,000 to 3,000 cubic meters of air per hour to be moving through, which is 30 to 50 cubic meters per minute, which is quite a lot of air. So I can understand why homeowners kind of think, well, I'll put it in a warmer space because, it'll be more efficient. It's going to strip the heat from that air so quickly, and it's just not going to replace it. So I'm assuming that that's the problem.
We've seen it in, somebody tried to put one in stables because the stables had loads of excess heat and it just chilled the horses.
Do you need help understanding your heat pump? Then pick up a copy of From Zero to Heat Pump Hero, an essential guide offering practical advice and basic instructions for new heat pump owners to maximize system efficiency. Available in print and on Kindle, link in the description. We actually had another question from a homeowner. They have a summer house in the Shetlands. Basically, the house doesn't have any land around it, but they have got a big cellar at the bottom, and the homeowner was basically saying whether it's possible to duct an air source heat pump in the cellar to basically try and drive air in and try and expel the air from the cellar. I mean, Is that theoretically possible, and how hideously expensive could that be?
If you want to talk theoretics, then yes, it is theoretically possible. It's no different really on a very basic level to what some supermarkets are now doing, and they are ducting, waste heat via an air source heat pump, and then it goes to outside. So again, theoretically, yes, it is possible. I think in reality, what would happen in a property, those ducts would probably get covered over, blocked, trees put in front of them, and eventually would stop being able to allow the air to pass. And as you pointed out earlier, the maths are relatively simple. As soon as that airflow starts decreasing, like Robert said, the free energy in that air starts decreasing, and we're back in the same situation we spoke about earlier. The other option is, do you look at a purpose-made technology, again, along the lines of exhaust air, where it's designed to work on ducting. You design to finite levels, the airflow you're coming in that's going to go out, and you design to certain pressure drop. That's a different level altogether.
I think we're all exactly on the same page, which is you've got appliances which are meant to go outside, where people are considering, I think purely because they're looking for a solution, putting that appliance in the incorrect location. But with the increasing technology now with ducted systems, there's definitely going to be, a lot more solutions for people that maybe are pushed on spaces. I think for a homeowner, if you're looking at your property and going, where can I put my heat pump? Can I put it, behind a shed? Can I put it in a cellar? Can I put it wherever? Thinking about the way that fluids actually work. Imagine a river, or a very smooth river. You're trying to push a fluid, air is just simply a fluid, down and keep it as smooth as possible and stop and not obstruct it and not make it backflow. If you put barriers, or you change the shape of that tunnel, that hypothetical tunnel in which the fluid is moving, it starts to eddy, it starts to swirl, it starts to get blocked up essentially. And that is essentially what we're talking about when you look at an air source heat pump. It needs a nice, relatively smooth intake of air, and it needs to be able to exhaust and recirculate that away. So if you place an object, whether that's a wall, or you place a tree or a car or a boat or whatever you want to put in front of it, you are causing that obstruction and that turbulence within the air, the backflow, which affects fundamentally the performance of the system.
Barry, when installing air source heat pumps in properties with very high ceilings, such as converted barns, how do you ensure that you get enough consistent heating throughout that space?
You tested me.
Yeah.
You factor it in. You factor in heat loss for a bit larger volume. It's a low temperature system. It's on all the time, so it does eventually stratify and heat the whole room anyway. It's not the problem everyone thinks it is. You just allow for a bit more for the volume. Underfloor heating's the best way to do it, because it's meant to be at low temperature at low level. Because with radiators, you're meant to it's circulating the air, so you've got more air to heat. But remember, a heat pump's on all the time, so all you've got to do is get it to temperature and then hold it. So it might take a bit longer and a bit more energy, but it gets there.
Underfloor heating is for human beings the best form of heating. The way it actually radiates, we call them radiators, they don't radiate, as we all know. Underfloor actually radiates up past you, and that effect it has on the human body is, as far as I know, certainly the last time I looked into it, was regarded as the best way for humans to have heating in their properties, and that's why it works so well.
Healthier as well, because it doesn't move the air as much.
Yeah, it's better for people with allergies and things. Be another consideration for people that are particularly sensitive to things like dust or pet hair or anything like that. Underfloor heating offers a non-convective way, I guess, is not actually forcibly circulating the air, and you don't get that tendency as much for with radiators, where heat will tend to rise, will convect naturally. As it reaches the outskirts of the property, it cools, it drops back down again. I mean, a heat pump will work with either, really, won't it, as long as it's factored in. But I find from our perspective, if people are open to having underfloor heating, it is what we tend to recommend.
You used to get that with gas boilers. When you put a new gas boiler in, you used to be able to smell it, because it used to kick all the dust up. And actually, I've had that positive feedback from people when we put a heat pump in, that the air feels better because it's not as turbulent. It's not got everything getting kicked out all the time. Because it's such a lower temperature, it's not got the same force coming through. You get a healthier house, really, a more comfortable house with a heat pump compared to another type of heating system.
We've seen quite a lot more rain recently, and I think that it's probably only going to get rainier and wetter as time goes on. So if a homeowner wants to install an air source heat pump and they are in a flood prone area, are there any preventative measures that you can actually put in to protect that heat pump?
I mean, you could move to Spain, couldn't you? that might be an option. I will defer to you two guys on that one, being more at the sort of cold phase.
We had a NIBE get flooded in a floodplain we didn't know, and it survived. I've got photos of the water halfway up the unit, and I was like, oh, that's written off. And he drained down, you got a hairdryer, dried it all out, and it's still working.
I think that's the benefit with it. It's an electronic appliance, isn't it?
All this PCBs at the top, so it was fine. It was just everything got wet.
It's also one of those weird quirks with the electronics, isn't there? That if you don't run a current through the board, essentially, whilst it's wet, it's absolutely fine. Dry it out, then run it. You've got no problems. The issue is generally people try and run it when it's wet, and that's what tends to fuse the sort of PCBs and that. But I need to see these photos, Barry, definitely.
He's actually been messaging me this week because he's like, right, I've got a load of blocks. How high can I get this heat pump? Here's the funny thing, that wasn't a floodplain. They built all the new houses down the road, so they've actually increased the surface water going into the burn, and the burn just choked up and just went woof, about a metre high.
It's becoming more and more common, that, isn't it?
So this is an incredibly wacky one. We actually had a homeowner that asked us whether it's possible to install an air source heat pump on a houseboat.
Put an air to air in, I wouldn't put a wet system in.
Got a great one for this. Slight tangent.
Is it an exhaust air, Rick?
No. Do you know what this is? I was blown away when I actually saw this. Best one I've ever seen was a ground source fitted on a houseboat, and the collector pipe. Honestly, the collector pipe was wrapped and fixed to the side of the boat, and this thing absolutely purred. It was fantastic. I was blown away. I sort of went, "But that's a ground source." Yeah, great. Well, where's your collector? And as I said it, he went to put, and it just dawned on me, and I thought, that's genius. That is absolutely genius. There you go.
There's a NIBE on the tall ship in Glasgow with the heat exchanger on the Clyde. It's not a stupid question.
I quoted one for a bus once. The guy had kitted it out with solar panels and the full works, and he was looking to really go off grid. And it was actually, interestingly, it was one of the first inquiries I dealt with when I was brand new to the industry, and I was still kind of, finding my way about it. And the guy goes, "I'm renovating a bus. Do you want to come and look at it?" And I was like, okay. He sent me these photos, and actually, as long as it's got a reliable, stable incoming voltage, isn't it? That's what's going to be the key there, is making sure that it's within the tolerance of the unit. But as long as it's got circulating air, as long as it's set up properly, as long as it's got minimum system volume, and as long as it's got a supply, why not? Whether or not that affects the warranty is a question for the manufacturer, though.
Aesthetics actually play quite a big part with regards to air source heat pumps. And the one thing that we continuously get asked is, are there any creative placement strategies that you can come up with for air source heat pumps that they don't seem to be as big an eyesore when you approach a property?
Homeowners are putting more of a focus, and rightly so, on the visual aspect of what a unit looks like. And with air source being the preferred option for most people, and obviously with things like planning regulations, which vary from part of the UK to part of the UK. Here, for example, the heat pump can't be visible from a road, and it must not obstruct your neighbour's view, and all these different things. Most manufacturers now that I know of that are keen to keep up with the market are developing visually appealing units. This push towards doing the matte black look, that's what they're loving at the moment. Cool grey, gunmetal. Other options that I've seen, and you guys are probably well aware of this, heat pump wrapping. It's the same theory as customizing your car, as you put a specific colour. It can be like a camo look, it can be something brick based, and again, it depends from manufacturer to manufacturer how it might affect the warranty, because a lot of heat pumps may have an inbuilt anti-corrosion coating, so it's worth checking those kind of things. But there is more availability now for people to actually customize the colour of the heat pump to make it match in with the surrounding, or make it blend in as much as they want.
Once they normalise heat pumps in every house, it's just going to be another box outside. We're quite happy to have 4 bins lined up outside our house, so another box is going to make no difference. You're right, it does feel like we've got wee fashion trends going on that go through different colours.
If I'm honest, that's where I think we're trying to get to, isn't it? How many people actually notice the white box boiler in their kitchen anymore, possibly even zero now, notice these things. The more normalised it becomes, the more we get used to these. I think you're right. I think we'll all stop trying to do fancy things with the colours and the fan shrouds and stuff, and I think there'll be a lot more standardised approach to the way these things look. Eventually, you'll stop noticing. There'll be so many of them, you'll just stop noticing. You'll tune it out like you do with lots of other things. When you buy a car and you drive it down the street the first time, and you go, everyone's got one of these cars all of a sudden. I only bought it yesterday, and suddenly everyone's been and bought one of these cars. It's not true, but actually it's that effect, isn't it? You suddenly notice it.
Right, do you think it'll go the same way as bathroom suites, and NIBE will do avocado green soon?
Oh, I hope so. Yes, please. like my wall behind.
If you live in an area with a lot of houses, the biggest pet peeve of people is noise. So that does, by extension, become an installation issue, because you are going to get the next door neighbor that's constantly complaining to the council saying, this guy's heat pump is keeping me up all night. How do you try and build that into your schematics and designs to try and put that heat pump in such a way that it's not going to, irritate the neighbor next door?
Not the issue everyone thinks. I've actually been involved with environmental health numerous times with noise pollution. So I had to learn about noise pressure and dissipation and all that. I had to learn all that. But that was 15 years ago, and I've never had a noise complaint since. What you've got to remember is the ear of the beholder, really. And you just got to be mindful of your location and pointing. If you're going to be within 3 metres and pointing at someone's bedroom window, yes, you might get a bit of disturbance with it. Renewable Heat have done about 1,000 heat pumps in the last 10 years, and I've not had one noise complaint off them.
I've even seen them installed outside of bedroom windows, and actually people had no comments. Whilst I wouldn't advise it necessarily, it's happened. I've been there. I've seen it myself. Maybe if you brought it up and said, "Oh, don't you find that's noisy?" It might be a different answer you get. And again, it's that perception thing. You know, there's a bit of almost a bit of an undercurrent at the minute of people almost asking it in the wrong way. They are noisy though, aren't they? Well, actually, maybe you should be saying, do you hear any noise? You know, and the genuine answer will normally be no.
We always get asked this as well. She says, well, will we hear it if we're sitting outside? And I was like, if you're outside, the heating's not on.
It always boggles me a little bit with this conversation of aren't heat pumps noisy? I think I can honestly sit here and say I don't ever remember anyone ever saying to me, when you install this boiler, is it going to be, is the flue going to be noisy? And yet it's been proven time after time, up to sort of 60 odd dBA sometimes, these boiler flues outside people's houses. No one's ever commented. Well, not that I've ever been involved in. Not once have I ever had that.
You can sit in the living room, you know when the gas boiler clicks in because you can hear it.
You're listening to the Renewable Heating Hub Homeowners Q&A, empowering consumers with the knowledge they need to make smarter heating choices.
Heat pumps can go everywhere. There's no problem jobs. Even if your house has got a high kilowatt value and a struggle for a heat pump, you'd be surprised how little energy you need to make it hybrid. If the upgrade works too much, look at hybrid and then start staging it.
Hybrids have a really important place in decarbonising and getting people onto heat pumps. We talk about these challenging properties and, in particular, properties that are on microbore, and again, you want to do an entire other episode on heat pumps on microbore. That's like you'll have us talking for hours. But when you get properties where they are very high heat losses comparatively, when I say the average single unit won't be able to meet it, let's say above 14 to 16 kilowatts, because that's what most manufacturers will shoot for that range. Having a hybrid means in most cases you don't need to change or upgrade heat emitters. Pipework can be left as it is, which when you're talking about a massive house where you've got all sorts of snaking pipework without lifting the floorboards, how can you guarantee what's actually under there where it's been teed off in 15 mil halfway down the house? You don't know. But a hybrid, for homeowners that are really keen to decarbonise, they offer such a fantastic solution to really bring down the use of fossil fuels in a property.
That's how the Dutch got so many heat pumps in. They just went hybrid straight away.
So thanks everyone for tuning in to this episode of Homeowners Q&A, and a big thank you to our fantastic panel, Rob, Rick and Barry, for their invaluable insights, and of course a huge thank you to NIBE for sponsoring this episode. Stay warm, stay green, stay tuned.
I think the boy band when you say it like that.
Yeah.
Like